In this video, we're going to talk about graphing linear inequalities. Graphing linear inequalities is very similar to graphing linear equations. We just have two other things to consider. Should the line be dotted or solid? Should we shade above or below the line? In this video, I'm going to go over a couple examples for your 7.2 Delta Math assignment. Alright, so here's our first question we're going to look at. 3x plus 2y is greater than negative 2. Now before we can graph this, we need to make sure it's in slope-intercept form. You guys can see this is not in slope-intercept form. We need y by itself. Take a minute, pause this video, and see if you can solve it for y, and then resume once you've done so. Okay, let's see if you solved it the same way I did. We're trying to get y by itself. So my first move is to move the 3x to the other side. If we move something across the inequality symbol, just like the equation, just like an equal sign, you just switch the sign of it. So I've got 2y is greater than, when I move the 3x across my inequality symbol, it is now a negative 3x. And I bring down my negative 2. Okay, next I want to divide everything by 2 so that y is by itself. If I divide everything by 2, I get y is greater than negative 3 halves x minus 1. Go ahead and just leave the slope as a fraction. Okay, so that's your first step. Make sure that it's in this form. Every once in a while the problem will already be in the form, but if it's not, make sure you do that. Now that it's in slope-intercept form, we're going to graph it just like it's any other line. Okay, this is my y-intercept. And this is my slope. I'm going to start with my y-intercept and plot a point there. So I'm going to go down here at negative 1. And then I'm going to do my slope of down 3 units and over 2. 1, 2, 3, 1, 2. And then I would connect those points. Okay? I'm going to get off the writing mode and go ahead and put that in there. So we were down at negative 1. We had a slope of negative 3 over 2. 1, 2, 3 over 2. So there's the line that we're trying to graph. But you see we have two things to consider. Should the line be solid or should it be dotted? Now in class, we will learn that you leave the line solid when you have a greater than or equal to or a less than or equal to. This time it's just a greater than. So we need to change this to a dotted line. And the reason why is because the solution is not a part of the line itself. It's everything greater than the line itself. So how do I represent that? Well, that's where the shading comes into play. So I want to represent everything greater than or above the line. So I want to shade above the line. Okay? If it was a less than, I would have went below. But since it's greater, I want above it. So anything in this purple region is a part of the solution set. Submit your answer once you've done all those steps. See the check mark. If you need some additional support, you can look back at the help here. Let's go ahead and try another question. Okay, so in the last problem, we were not in slope-intercept form. This problem, y is by itself. So we're already in slope-intercept form. We don't have to solve for y. We can go ahead and start graphing. My y-intercept's at negative 1. My slope is 5, 6. I'm going to go up 5 units. I'm rising 5, going over 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's a positive slope, so that's why I went up first and then over. Remember, you always go to the right. If it's negative, you would have went down. Okay, so we have the line here. Do I want it solid or dotted? And I want this one solid because of the equal sign underneath the less than. This is less than or equal to. So we do include the line itself. Okay, so I'm going to leave it solid. And then for the shaded region, I want everything less than this, so below the line. So I'm going to put the shade below my line. All right, let's try another one. So this one's very similar. I'll do this one quickly. My y-intercept's at -4. My slope is up 3. 1, 2, 3 over 4. 1, 2, 3, 4. Okay. And this one should include the line, so I'm going to leave it solid. And I want everything below it since it's a less than. Okay, now I'm going to try to find one with a negative y. So I'm not going to do this one. No. Here we go. So what happens when you have a negative y? We'll figure that one out. All right. So go ahead and try your best to get y by itself. Pause the video, move the 2x over, and then try to divide by the -1. And then I'll walk you through it here after you tried it. All right, so the first step you should have done is move the 2x. So I'm going to be left with the -y. I am moving the 2x to the other side, so it's now a -2x. Still have your +5. Okay, next thing we want to get rid of, so don't forget, that negative is not disappearing. It's still with the y. I want to get rid of the negative. So I need to divide by a -1 to get rid of it. So just like any other coefficient, you got to divide it from every term. Okay, so the negatives, they are inverses of each other, right? So that's going to make it a +y. Okay, but here's the trick, or here's the thing that many forget. When you do that, you actually have to flip your inequality. Whenever you divide by a negative, you have to flip the inequality. Check that out. I switched it from a greater than or equal to a less than or equal to. Why did I do that? Because I divided by a negative number. Anytime you divide by a negative, you have to flip your inequality. Okay, the rest of it's the same. So -2 divided by -1 is 2. And 5 divided by -1 is -5. Okay, so now I'm ready to graph that. This one's going to start down at -5. And it's going to have a slope of 2, so up 2 units and over 1. Okay, let's go ahead and do that part. Starts at -5, slope of up 2 over 1. This line, so if you remember, it was y is less than or equal to, so I am going to leave it solid. And then for my shaded region, I'm going to go ahead and rewrite what I had. So give me a second. Let me rewrite what I had. Okay, so this is what we were able to solve it to. We have y is less than or equal to 2x minus 5. Went down to -5, plotted my point, went up 2 over 1. Less than or equal to, so it's below the line. And then I need to keep this line solid because of the little equal to sign underneath. All right, so that should be it. Let's go ahead and give that a try. Okay, there you go. Let's do one more with the negative. Let's see if I can find another one. Okay, so here's another one. Once again, I'm going to pause the video. I hope you guys are taking the time to working them out by yourself first. That's going to help you tremendously. So go ahead and take a second or two, try to get the y by itself, and then come back after you've tried it. Okay, so I went ahead and solved for y, and this is what I got it down to. After moving the x and dividing by -3, I have y is greater than or equal to, I had to flip my symbol again since I divided by a negative. So greater than or equal to 1/3 x minus 6. So I'm going to go down to -6, plot a point, and then go up 1 over 3. All right, and then when I shade it, I'm going to have to shade above the line. Okay. Go down to -6, up 1 over 3. The line's going to stay solid. I'm going to shade above the line like we talked about. So like that. All right, so there's your lesson video over graphing linear inequalities. Hopefully you guys are finding these videos helpful. If you need some further assistance, let me know. For this assignment, you only need to complete 10 problems. So you're just trying to do 10 of them. Thanks for watching, and I will see you next time.